Hi, I'm Melanie Grudinsky, a junior at the University of Arizona studying systems engineering with a minor in biosystems engineering. On campus, I am involved as a cheerleader and also an engineering ambassador. I am planning on applying for the Accelerated Master's program, and I also work on campus as an undergrad research assistant in the Smart Life in Motion lab, where I am learning and researching all about human factors and ergonomics. You might be thinking, what is systems engineering? Well, systems engineering is designing, implementing, and managing large complex systems over their entire life cycles. Industrial engineering is optimizing those complex systems and processes. And engineering management combines business and engineering to create engineering leaders in the industry. As a researcher, I am working here in the Smart Life in Motion lab under Dr. Sol Lim, lab director and assistant professor. In the SLIM lab, we are assessing human motion by combining biomechanics, wearable sensing technologies, and data analytics to improve human performance and life. In the lab, my current project is the Intelligent Yoga Training System for people with low vision. And I got involved in research by starting with undergraduate research units, and now I am working in the lab. Our research project to create an intelligent yoga training system with wearable sensors and vibrational feedback started because we found that people with vision impairments tend to experience health concerns due to their lack of physical exercise. Yoga, however, can be a good physical exercise option because it helps improve balance and posture while being relatively stationary. The system will begin with an adaptive and customizable AI yoga instructor system that populates a personalized yoga practice plan for each user. With that plan, while the user is performing the steps and following the instructions from our system, we will track their posture and balance real-time using embedded IMU sensors. Based on the correctness of the user's pose, our system will provide repeated verbal instruction as well as localized vibration feedback to guide them into the correct pose. Here is an example of one of the network diagrams that would be used to auto-generate a yoga pose sequence for various users considering their functional capabilities. The blue path shows a scenario for a user with low balance abilities. All of these poses have both feet on the ground and do not require advanced balance. For this user, the clasped eagle is an advanced balance pose they would not be asked to perform. The connection arrow would be disabled for this particular user. As an initial step towards building such yoga training system, we are conducting an in-lab feedback modality study to determine whether providing additional non-visual feedback would be effective and acceptable to visually impaired users in virtually learning yoga, and if so, which form of feedback is the most adequate. The 4 different types of feedback we are analyzing are no feedback, repeated verbal instructions, localized vibration feedback, and a combination of both repeated verbal instructions and localized vibration feedback. In our study, the participant will start by completing a set of surveys. The first survey is the demographic questionnaire, followed by the body discomfort and Edinburgh handedness inventory. Next, the participant will be led through the anthropometric and functional grip measurements. Various balance measures will also be completed to get a base measurement of the participant's balance abilities prior to the yoga sessions. This diagram shows the 10 body segment locations for the sensor attachment. The participant will use this diagram and the instructions to correctly place the sensors onto their body. The 10 sensor attachment locations include the left upper and lower arm, the right upper and lower arm, the left and right shank, the left and right thigh, and the 2 locations on the back, T6 and S1. The most important locations we identified from a previous study were the lower and upper arms. Once the participant has the sensors attached, the yoga session will begin. This task analysis on 16 yoga poses and the photo diagram shows some of the poses that may occur in the participant's yoga practice plan, as well as the instructional steps that will guide the learner's movements. During the session, my research team and I will be guiding the user through the instructional steps to complete each pose. Here is an example. Lower your arms out to the side. Turn both your palms to be facing forward. Keep your hips facing forward and twist your upper body towards the right side. While the participant is doing the yoga, I will be monitoring the poses and sending out feedback when there is an incorrect pose. I will either send a repeated verbal instruction, a vibration, or a combination of both. This shows a 10-sensor diagram set up on CAS Architect, developed by Kyle Norland. Through this system, I am able to click on the orange buttons shown on the left of the diagram to send out a vibration to the sensors. The sensors will vibrate on the body, indicating to the participant which part of their body is in the incorrect place for that pose. The IMU sensors also stream acceleration and angular velocity data to the Raspberry Pi computers. Following each yoga trial, the participant will be asked to complete the Yoga Experience Survey to evaluate the difficulty of learning, effectiveness, acceptability, and their overall experience with our system. We plan to continue to improve and develop our system following this feedback study, as well as continuing our other research projects, which can be found on our SlimLab website. Another part of the research is getting to produce publications and give presentations at conferences. For example, in 2020, I presented at the Human Factors and Ergonomics Society's 64th International Annual Meeting. It was really fun getting to present my work on the yoga project and getting to listen to other people's projects as well. Overall, this engineering research has been a really exciting and rewarding opportunity for me. I have learned many new things and gained valuable experience for my career moving forward in the industry. I plan to continue my research here in the SlimLab with the Accelerated Masters program to extend the yoga system to a broader user population, such as for older adults or people with other capabilities.